have received many questions on YouTube and many messages in order to explain how a blockchain is working, how Bitcoin is actually working, and how it is actually using the blockchain in order to create consensus in the same time, in order to achieve verification that a transaction exists in the blockchain, and how WebDollar was created and how WebDollar is using the blockchain. In order to explain how WebDollar works, I created a small presentation in Google Docs. You can also download the presentation, you can see the slides, but the purpose of the presentation is to be very simple, to be very basic, in order to understand the basics of a blockchain, how the transactions are created and verified by everybody in the network. And if you have other questions and maybe something was not very clear, you can leave a comment, and yeah, let's see how it works. So now I'm explaining how the blockchain is being used in WebDollar, but also in Bitcoin as well, and to see the difference between the Bitcoin blockchain and the WebDollar blockchain. As you know, Bitcoin is using a blockchain. A blockchain is a chain of multiple blocks that are stacked one on top of another one. So here we have 3 blocks as an example, but the main idea is that a block has a hash of the previous block. So by using this hash of only 32 bytes, you can validate the entire chain of your blockchain. For example, for block number 3, its previous hash is hash of the block number 2. But in order to calculate block number 2, you also have the hash of the previous block number 1, and so on. So if I am interested, I can validate that the block number 1 is part of this chain by verifying its hash can be determined in order to get the hash of block number 3. So by doing this, I can see that the block number 1 is part of its history, of this blockchain history. The main idea of the Bitcoin blockchain is that each block contains a list of transactions, and this list of transactions is building a Merkle tree. It is the block is storing the Merkle tree root, but in order to calculate the Merkle tree root, you need the transactions. And this is another diagram that is explaining the same concept of the blockchain. Here you can see the block number 10, the block number 11, and the block number 12. So this is the prev hash, the hash of the previous block, and so on, the timestamp, the nonce, and a few more other data. But this is the Merkle tree root, and you can see over here we have 4 transactions: TX0, TX1, TX2, TX3. From those transactions, we calculate the hashes: hash 0, hash 1, hash 2, hash 3, and using those hashes, we can calculate the hash of the parents: hash 0, 1, hash 2, 3, which are computed from concatenating its children. And by using hash 0, 1, hash 2, 3, we calculate the Merkle tree root, the final hash, which is the concatenation of hash 0, 1 with hash 2, 3. The main idea is that in order to validate a transaction, I don't need all other transactions. For example, if I want to validate transaction number 3, I need only hash 2, I need only hash 0, 1, and I can calculate the Merkle tree because it will be identical. So by doing this, I'm skipping downloading transaction number 2, I'm skipping downloading transaction number 1, and as well transaction number 0. I don't even need the hashes hash 0 and hash 1 because I need to download only hash 0, 1. By doing this, I can prove that this transaction TX3 is actually in block 11. This is a very fast and efficient way to verify that the transaction is in the blockchain and on this block number 11. So by using these blockchain chains of blocks and using this Merkle tree, I can validate very fast that the transaction has been included in the block. And for example, here is a more complex Merkle tree, which has not 4 transactions, has multiple transactions, and it is the same. For example, those at the bottom are the hashes of the transactions. So if I want to validate the transaction n, I need to download only the hash n, hash m. I can compute hash mn. I need the hash op. I can calculate its parent, hash MNOP, and in order to download, to calculate the parent, HAJKLMNOP, I need only HIJKL. The hash, this hash, and I can calculate its parent because it's just the hash of the concatenation of those two hashes. And in order to calculate the root, the hash ABCD and so on, I need only to get the hash ABCDGFGH. So in order to do that, I just download that hash and I can validate that root. It's a very efficient, and it's super efficient in order to prove this transaction n is part of this miracle tree. And Bitcoin is using UTXO, unspent transaction, so you need to have a proof that this transaction as an input was included already in the blockchain in a specific block, and it's over there and so on. So using this miracle tree, you can validate very fast and very efficient that the transaction is already over there. Instead of downloading all those transactions or all the history and so on, you can download only what is necessary in order to see if it's already over there. So the Bitcoin is pretty much a ledger. It's a ledger of transactions, but it's not very efficient. Because most of the people, they do recurrent transactions. For example, Bitcoin is building a ledger like, for example, takes one, A is just sending 1.1 coins to B, the second transaction is B sending to C 0.5, B also is sending to A 0.2, B is sending to C 0.2, and C is sending to A 0.2. And you can see there are a lot of recurrent transactions, and the list can go on and so on. So it is not very efficient. Because you don't really need to store the history of the transaction in order to prove that you have enough funds, because this is what Bitcoin is trying to achieve, is to make a currency in order to show that you have enough funds to transfer. So you have the funds, and that you are the owner of all of those funds. So you can actually build a ledger with balances, because you are interested only to see if you have enough funds. So this is a mini blockchain stored as an account tree. You can see this account tree has in this diagram the accounts, all of those three balances of C, A, and B, and so on. And you can see the final value that A has 0.2, B has 0.2, and C has 0.7. So I don't keep all those transactions that can go on and on and on, because it's not very efficient. And you can prove in the same way that B has 0.2 with the miracle tree I just described a few minutes ago, that you don't really need to download the entire account tree, this tree. You need only to download the data of B, that he has 0.2. You can download the other hashes of this account tree, and in just the logarithmic hashes, you can prove that B has that amount of money, that amount of funds, and he can prove that this is included in the blockchain. How? This is called mini blockchain scheme. That those are blocks: block 1, block 2, block 3, and block n, and so on. And this block has one more data, which is the hash of the miracle tree of this radix tree. So it is called Patricia Merkle tree, that contains the balances of everybody, and you just calculate the hash of all this tree that goes up and up, and you store that hash, the root of your tree, in this block. And by doing this simple verification payment, SPV, a simple payment verification, you can verify that the balances are all right over there. So, but there is also a better way to store data. So for example, most of the dictionary, even in English and in many other languages, most of the words have some prefixes. They are very similar
some of them, and some of those words are containing different common letters or different common of prefixes and so on. If you have more and more words, then automatically more and more words gonna have more prefixes. So this is called radix tree, which is a tree constructed on prefixes. For example, Romane. Romane is just you can just search based on the prefixes, and you find R, O, M, A, N, and E, and you found the word Romane. And by doing this radix tree, you are storing very efficiently in your database, instead of doing a simple ledger saying that Romane has that amount of funds, Romanus has that amount of funds, and so on. And keep in mind that there are over 7 billion people. So if you want to have a global currency or a global blockchain, for that anyone can use it, you need to think that you're gonna have to store at least 7 billion entries in your blockchain, at least one for each person. And some people, as they have multiple bank accounts and so on, so there will be over 7 billion accounts. And using this radix tree is very efficient in order to store your data. And for example, in order to prove that you have this data of node number 6, which is Rubicon, you don't need to download all other data like 3, 1, 2, 4, 5. You need to download 6 and 7. The one you are interested is 6, and then you just need to download the 2 more hashes, and that's it. You have the proof that that 6 is in this radix tree. And it's very efficient by using the same concept like I described in the Merkle tree, how in the Bitcoin is using.
Thank you very much for watching this, and I hope it was crystal clear. If you have any kind of questions, if you didn't understand everything, leave a comment below with questions or with ideas of what should I talk about in the next videos. I hope you understood how this thing is used in the WebDollar cryptocurrency. I also want to tell you the values of a blockchain, that the blockchain is immutable, so you can prove that something happened in the past, that the transaction exists over there. Nobody can change or alter the data in the past. Everybody can see, can verify the entire flow of the transaction, so everything is verifiable. But in the same time, you have a proof that those events have been created in the past and nobody can actually change it so far. You need the quantum computer in order to modify or edit the blockchain in the past, or a very big network of computers. Thank you very much, and subscribe.